And now we are going to look at question 3, which is analytical geometry. So this is an easy part, but a challenging one as well. It just needs you to follow the basic rule of your geometry or your analytical geometry, where you just analyze and then give out your calculations together with your answers. So it says the diagram, or in the diagram A, which is 5:3 on that Cartesian plane, and B, which is 0 is to a half, and then C and E, then E you're given the coordinates of E, which is 6:2 - 4, are the vertices of a trapezium having BA and CE being parallel to one another, which is BA is parallel to CE. Then D is the y-intercept of CE, and then they told you that CD is equal to DE. So the first one in question 3, which is 3.1, it says calculate the gradient of AB, which is very easy. So they already gave you the coordinates of A, so I'm just going to write them down. So the coordinates of A are 5:3. Then the coordinates of B are 0 and a half. So to get the gradient, we know that the gradient is equal to y2 minus y1 all over x2 minus x1. So you can choose for yourself. So I'm going to choose A to be 1, and then I'm going to choose B to be 2. So I'm going to say a half minus a 3 all over 0 minus a 5, and then when you punch in that into your calculator, you're supposed to get a half. Let's just double check our answer. So it's 1/2 minus a 3 all over 0 minus a 5. Yeah, our gradient, which is the gradient of AB, is going to be a half. And one thing about gradients, if a gradient is positive, your line must be in this direction. So if your gradient is positive, but if your gradient is said to be negative, it must face the other way around. So that was 3.2, and now we go on to that was 3.1. Now we go on to 3.2. So in 3.2, they say determine the equation of CE in the form of y is equal to mx plus c. So if you can see the CE, we only have the coordinates of E and not the coordinates of C. So, but we were already told that AB or BA is parallel to CE. So we know that the relationship between parallel lines, they have equal gradients. So since AB is parallel to CE, that means the gradient of AB will be equal to the gradient of CE, which is going to be a half. And now we're going to simply use the coordinates of E, which are 6:4, together with that gradient that we just got there, that is a half, to get the coordinates, to get the equation of the line CE in that form, y is equal to mx plus c. So I'm going to say y minus y1 is equal to m times x minus x1. So we're going to simply use the coordinates of C to get that equation. And then so we're going to say y plus a 4, since 4 is negative, is equal to a half times that x minus 6. So we have firstly we're going to multiply by a half, then we take 4 to the other side. So it's going to be a half x minus a 3, because we know that a half times a minus 6 is going to be a negative 3. Then we're going to say y is equal to 1 over 2x minus 3. Then we're going to say minus 4. So which means that our equation is going to be a half x minus a 7, because minus 3 and minus 4 give you a minus 7. So that would be the equation of the graph. And then we go on to question 3.3. Yeah, 3.3 is a series of questions, if we can see. Yeah, so 3.3, so 3.31, since it's a series of questions, they say calculate the coordinates of C. So to get the coordinates of C, this is what you're going to do. So they already told us that on the statement that CD, right, is equal to DE, which means they are equal in length, and that means that D, the coordinates of D, is the midpoint of that line. So D is the midpoint of that line. So firstly, let's establish the coordinates of D, then we go and find the coordinates of C. D is a y-intercept on that line CE, which we just got the equation of. So meaning that the coordinates of D have to be a 0 is to a negative 7. And now we're going to use the midpoint formula to get the coordinates of C. So that D is the midpoint, so this is what we're going to do. So we're going to say X, and now we're going to look at CE. So we're going to say X of C plus X of E all over 2 have to give you that 0 there. Remember, we are looking for the coordinates of C. So we don't have this value here where it says C. We already have E all over 2 equals to 0, which is the 0 from the D, or the coordinates of D. So I'm going to start with the x's first, and then let's go on to the y side. So we're going to say the y of C plus the y of E all divided by 2 has to be equal to, remember the midpoint is coordinate of D, which is negative 7. So that is how you would do that question. Now we're going to calculate them individually. We're going to get X first, and then we're going to get Y on the second side. So here we're going to have X of C plus the coordinate of E. The X coordinate of E is a 6 divided by 2 equals to a 0. So when we solve that, when we cross multiply, we're going to have the X of C. When you cross multiply, you're going to get okay, it's going to be plus 6 here, it's going to be 0 here, and then the X value of C has to be a negative 6, and as you can see, it's on the negative x-axis. Then that will be the X value for C. And then when we continue to the Y side, so we're going to say YC plus the coordinate of E, which is the Y coordinate of E, is a negative 4. So we're going to say YC plus a negative 4 is going to be a minus 4 all over 2 equals to a negative 7. And then after that, we're gonna cross multiply again. right? We're going to cross multiply. We're going to say 2 times a negative 7 is going to be a negative 14. So yc minus 4 will be equal to a negative 14. Then when you transpose, that 4 will be positive, so you're going to have minus 14 plus a 4, which gives you a negative 10, because the y value for c is also negative and the x value for c is also negative. Therefore, your answer will be that the coordinates of c are negative 6 and negative 10. Those are the coordinates. And now we move on to 3.3.2, which is, we're still in 3.3, which is a series of questions. So 3.32. So 3.32 says calculate the area of the quadrilateral ABCD. So now E is excluded. So if you draw a line, from D to A, that is your quadrilateral. So your quad will be something like this, shaped like this. It will be shaped just like this. Yeah, I'm just doing the sketch for that quad. So you have A here, you're gonna have D here, but C is a little on the bottom side, so I have to stretch it. Yeah, so that will be, yeah, it will be something like that, because C is on the lower side. So they want the area of that shape, which is A, B, C, D. And now once you're done with that, you're gonna cut your shape into this part so that you get two triangles there, so that you can get the area of that shape. And if you can see that B and D are on the vertical line, which is the y-axis, so you can easily get the distance between the two of them. So to get the area, then let's move on and see how we get the area. So to get the area, we need to find the area first, the area of triangle BCD. So to get the triangle of BCD, we need the length of BD, and also we need the length of CD, so that we can get the accurate values. So we're gonna say the area of that triangle is going to be half. It's going to be half base times height, so it's going to be half 7.5, and then you're gonna say a 6, and then when you punch in that, you're gonna have, if we double check, so 1/2 times 7.5 times a 6, you're gonna have to get 1/2 times 7.5 times a 6, that is 22.5 units squared. So we are not done yet. We are also going to look at another triangle that make up that quad that they told us, which is ABCD. So we're going to find the area of triangle ABD as well. So we're going to do the same thing. It's going to be the same thing. We're going to say half, and then you're still going to have that 7.5, because we have 7.5, and then you're going to say multiply by a 5. And then when you do that again, remember you're looking for the quad. So you must, when you get the answer for this triangle and for the following triangle, You must also add them both, then you get the area of the whole quad. So it's going to be 7.5 times a half times a 5 this time around, and then you're gonna get 18.75 units square or unit square, and then you're gonna add your answers. So it's going to be 22.5 plus 18.75, and then 22.5. Yeah, then your area for A, B, C, D will be 41.25 units squared. So that is how you would find the area of that quad. And now we move on to the last one, which is 3.4, which is also in series as well. So in 3.4, they're saying that if point K is the reflection of E in the y-axis, then 3.41 says write down the coordinates of K. So they told us that the point K is the reflection of E when it's reflected about the y-axis. So we've dealt this with a similar question in paper 1, where we speak about the reflection. So K is the reflection of E, so it's reflected about the y-axis. So what happens when a point or a line or whatever is reflected about the y-axis? So if the original point were to be x and y, then once they say it's reflected about the y-axis, we know that we simply change the x coordinate. We just put a negative there on the x coordinate, and then we keep everything the same. So that is what is going to happen. So now let's look at point E. So point E is, if you remember that point E is 6 is to a negative 4. So the reflection or the reflected value or the reflected point, it would be negative 6 is to a minus 4. So that is how you get your mark for that question. So which is just 2 marks. And then 3.4.2, which is also in series. So they like to give questions in series. So which is, it has A and B. So it says calculate the perimeter, which is the first one, which is part A on 3.4.2. It says calculate the perimeter of the triangle K E C. So we know that a perimeter, you just add all your sides, and that is how you would get your perimeter. So but we need to go to that triangle KEC, which is the new triangle. So we already know that KC is 6 units, and then KE is 12 units, which is 12 units would be your hypotenuse this time around. So if I can just do a silly sketch or a simple sketch. So you have K and E. So this would be K and E. Then at the bottom we're gonna have point C, I believe. We're gonna have point C at the bottom. So this would be your 90 degrees because it's a straight line from K to E, because it's just a reflection or the point where it's reflected. So here we have 12 units, and then from K to C we have 6 units, and then we need this value here, which is the hypotenuse if you apply theorem of Pythagoras. If you use theorem of Pythagoras, since it's worth 4 marks, we don't have to stress ourselves. If we use theorem of Pythagoras, we know that CE squared has to be equal to a 12 squared plus a 6 squared. Yeah, a 6 squared. So let's try to find that. So 12 squared plus 6 squared will be 180. So CE squared is 180, but we're looking for CE. And then when we root our answer or the value of 180, we know that we're going to get 13.42. So that would be the value of CE. So the question said that we must find the perimeter of this triangle. So the perimeter, we know that you just add all your sides. Then that's how you get your perimeter. So the perimeter of the triangle KEC, so we're just going to say 13.42 plus 12 plus a 6, and then our final answer is going to be, the perimeter is going to be 31.42 units. And then lastly, we need to find, which is B, which is part of 3.42 as well, which is our last question on question 3. It says we need to find the size of the angle KCE, which is the angle there. So what you need to do, you need to find that angle there, which is in between. So if you go back to your triangle, so if you check which angle they're talking about, KCE, so the middle letter has to be that angle, which is KCE, which is you're looking for this theta there. So that theta that you're looking for. So if you don't want to make use of the new value, you can use the value that you had before, which is the value of KE and the value of KC. So if you use theorem of Pythagoras, or not theorem of Pythagoras, but the SOHCAHTOA, which is they call the trigonometric ratios. So if you use that one, you can see that you have an opposite to that angle, and you also have an adjacent to that angle. So that means you're going to use tan. So tan theta has to be equal to 12 over 6. So you're looking for theta, so meaning you're going to say theta is equal to, then you're going to say shift, so you know that 12 over 6 is a 2, then your theta will be 63.43, and that is how you would find your size or the angle of KCE for 3 marks. So question 3 is 21 marks, and that's how you get your full 21 marks for question 3. And that is the end of question 3.